Hello everyone, welcome to Smart Interviews YouTube channel, one-stop solution to AS interviews. In this video, we are going to discuss CodeChef Starters 180 Division 4 First 4 problems. Let's get started. Coming to the first problem, CodeMat. CodeMat is an annual programming competition organized by the Mathematics and Computing Society at IIT BHU. So last year, the event had X participants, while this year it attracted Y participants. Determine whether this year's event was more successful by checking if Y is greater than X. So if it was more successful, you have to print yes, otherwise you have to print no. So the problem is very simple. You'll be given two integers x and y. So where x denotes the number of participants last year and y denotes the number of participants this year. So you have to check if y is greater than x. If y is greater than x, you have to print yes. Otherwise, you have to print no. Let's code it. So first we'll read x and y values. So in Python, we'll read the input using input and we'll split that string and we'll convert that into integers and we'll store it in x and y. And we have to check the condition that if y is greater than x, you have to print yes, else you have to print no. Let's run it. Okay, we got the output as yes. Let's see the sample one. So the expected output is yes. So we got the expected output. Let's submit it. That's it. It got submitted. Coming to the second problem, maximum ones. You're given a binary string S of length n consisting only of characters 0 and 1. You're allowed to perform at most key operations on this string. In each operation, you can choose an index I, where I is ranging from 0 to n-1, and update character at position I as follows. S of I is equals to maximum of S of I comma S of I plus 1. So here the maximum is taken in the numerical case where 1 is considered greater than 0. This operation essentially means that if S of I plus 1 is 1, then S of I becomes 1, regardless of its previous value. Your task is to determine the maximum possible number of ones in the string after performing at most k such operations. So here, in each operation, what it does is, if let's take any two characters, 0 and 1, it will convert it to 1 and 1. If you take 0 and 0, then it will be 0 and 0. And if you take 1 and 0, then it will be 1 and 0. And if it is 1 and 1, it can be converted to 1 and 1. So using these operations, what we have to do is, you have to determine maximum possible number of ones in the string after performing at most k such operations. So in the input format, you will be having t test cases. In each test case, you will be having two integers in the two lines of input. The first line you will be having n and k, where n is nothing but number of characters in the string, k is nothing but the number of operations you can perform. And in the second line, you will be having a binary string of length n consisting of characters 0 and 1. So in the output, you have to print the maximum number of ones. So let's see the sample test cases. So coming to the first test case, you'll be having a string of length 3 and we can perform k equals to 1 operation. So if you see the first test case, you can apply the operation at index I. If you write the indices 0, 1, 2. So we have to convert this 0 to 1. So how can you do it? So if you consider this as I, so this is I plus 1. So you can replace this I with maximum of S of I comma S of I plus 1. So it will become 1, 1 and 1. So after one operation, what's the total number of ones? It is 3. So the output for the first test case is 3. If you take the second test case, 0, 0 and 1, and k is equals to 1 and n is equals to 3. If you write the indices 0, 1 and 2. So you have to convert these two zeros to 1. So we are having only one operation. So how many zeros you can convert into 1? Only 1 0. Okay. So can you able to convert this 0 to 1? Is it possible? So if you consider this as I, if it is I plus 1, if this is I plus 1, so what can you replace here this 0 with? It can be replaced with again 0 only, because maximum of s of I comma s of I plus 1. So we cannot convert this 0 to 1. Okay, can you able to convert this 0 to 1? If you consider this as I plus 1, so we can replace it with maximum of s of I comma s of I plus 1. So we can replace it with 1. So it will become 0, 1 and 1. So after k equals to 1 operation, how many ones are present in the output string? It contains only 2. So the output is 2 here. If you take the third test case, it is similar to the second one. The only thing is, it is having 2 operations. It is having 2 operations. So we know that we cannot able to convert this 0 to 1 initially. But can you able to convert this 0 to 1? Yes. When k equals to 1, you can convert this 0 to 1. So it will become 0, 1 and 1 when k equals to 1 in the first operation. In the first operation. In the second operation, can you able to convert this 0 to 1? Yes, of course. You can take this as I, this as I plus 1. So you can replace it with maximum of s of I comma s of I plus 1. So in the second operation, it will become 1, 1 and 1. In the second operation. So after performing 2 operations, what's the maximum number of ones in the string? It is 3. So hope you guys understand. Okay, let's take one more example and understand better. Let's say you are given a string 0, 1, 0, 0 and 1. In this case, let us also denote the indices 0, 1, 2, 3, 4. Okay, let us assume that we have infinite operations. Let's k equals to infinite operations. So if you're having infinite number of operations, is it always possible to convert all the zeros to 1? Is it possible? Let's check it. So if you want to convert this 0 to 1, is it possible? Yes. So I plus 1 is 1. So already we have seen that 0, 1 can be converted to 1, 1. So this 0, 1 can be converted to 1, 1. So next, can you able to convert this 0 to 1? We cannot do it directly. So first we have to convert this 0 to 1. So you have to convert this to 1, 1. So later you can convert this 0 to 1, 1. Let's say if you are having infinite number of operations, are you sure that you can convert all the zeros to 1 in this example? Yes, right? Okay. Let's take one more example. Let us take 0, 1, 0, 0, 1 and 0, 0, 0. So same here, k equals to infinite. You have infinite number of operations. You can perform the operation any number of times. So can you able to convert all the zeros to ones? Can you able to convert this 0 to 1? Of course, you can convert this to 1. Can you able to convert this 0 to 1? You cannot directly convert, but after converting this 0 to 1, and you can convert this 0 to 1. Now, is it possible to convert these two zeros to 1? Is it possible? Even though if you are having infinite number of operations, can you able to convert the zeros to 1? Is it possible? So if you take 0, 0, you will get 0, 0. Do you have any another one here to convert the 0 to 1? No. So if you are not having any leading one after this consecutive zeros, if you're not having one at the right side, you cannot able to convert these zeros to 1. Yes or no? If you're having 1 here, you can convert this to 1 1. Again from here you can convert this to 1 1. So if you're not having this 1, even though if you're having infinite number of k operations, can you able to convert this two zeros to 1? Is it possible? No. So what shall we do is, first let's try to find out the unmodified zeros. So in the given string, let's try to find out the total number of unmodified zeros. That means even though if you're having infinite operations, you cannot be able to convert these zeros to ones. So how will you get these zeros? How will you get the zeros count? Simple. So you will iterate from the last. So you'll check if it is 0. Let's take unmodified. Initially it is 0. So when you found 0 here, you'll increment the count. When you found the 0 here, you'll increment the count to 2. And when you found 1, so you have to break it. So when you found the 1 here, so all the zeros that are present here, if it is having infinite operations, they can be modified to 1, right? So this is how you will find out the total number of unmodified zeros. Even though if you're having infinite operations, you cannot modify this unmodified zeros. Okay, so after finding this, what is our problem statement? You need to find out the total number of ones you can place after k operations, right? So even though if you're having infinite operations, you cannot modify this unmodified zeros. So now let's take k equals to, so what's the total number of zeros here? What's the total number of zeros here in this given string? The total number of zeros is equals to 5, right? The total number of zeros equals to 5. So from these 5 zeros, can I eliminate these unmodified zeros? Even though if you're having k equals to infinite operations, it is not possible to modify. So I will subtract 5 minus unmodified zeros, nothing but 2. This is nothing but total zeros, and this 2 is nothing but unmodified zeros. So this is nothing but modified zeros. So how many zeros you can able to modify? 3. So modify zeros is equals to 3. So if you're having k equals to infinite operations, you can modify all these 3 zeros to 1. Okay, what if k equals to 2? If you can able to perform only 2 operations, from this 3 modified zeros, how many zeros you can convert to 1? You can able to perform only 2 operations. So you can able to convert only 2. So among this, what you have to take? You have to take the 2. Let's say if your modified zeros is same, if your modified zeros is 3, and let's say k equals to 5. At most you can perform 5 operations, but at max how many zeros you can modify? You can modify only 3. So here you can modify only 2. Here how many you can modify? Only 3. Even though you are having 3 modified zeros, you are having only 2 operations. So that's why only 2. That means you can convert ones, 2 number of ones. And here how many ones you can convert? 3 number of ones. So what's the total number of ones in the string? They are 2. So total number of ones plus, among this what you have to take? Among 3, 2, you have to take the minimum of 3, 2. And here 3, 5. what you have to take? Minimum of 3, 5, nothing but 3. So total number of ones plus minimum of, so the answer will be total number of ones plus minimum of modify zeros, comma, key value. So this is our final answer. So what you need to find here? You need to find out the total number of ones and you need to find out the total number of modified zeros. So how can you get this total number of modified zeros? To get this total number of modified zeros, you need total number of ones and you need unmodified zeros. So first we'll try to find out the total number of zeros and total number of ones. So after finding the total number of zeros and total number of ones, we'll try to find out total number of unmodified zeros. So if you able to find out this total number of unmodified zeros, you can get the modified zeros and you can get the final answer. Okay, let's code it. In the first line, you have to write t number of test cases. In each test case, you will be having 2 lines. The first line consists of n and k. N is nothing but length of string, k is nothing but total number of operations. And you have to write the string. So in the first case, you have to find out the total number of zeros and the total number of ones. So ones is equals to 0 and total number of zeros is also initialized to 0. So for I in range n, if string of I is equals to 0, then you have to increment zeros, else you have to increment ones. Next, you have to find out the total number of unmodified zeros. So how can you get these unmodified zeros? You have to iterate from the last in the string. So n minus 1 comma minus 1 and minus 1. So you have to check if string of I is equals to 0. You have to increment unmodified zeros. So these zeros cannot be modified even though if you are having infinite k operations. If you found 1, you have to break it. So now how can we get the total number of modified zeros? Modified zeros is equals to total number of zeros minus unmodified zeros. So the answer is total number of ones plus minimum of modified zeros comma k. Let's run it. Okay, we got the expected output for the sample input. Let's submit. That's it, it got submitted. So the time complexity is t into n. So here we are iterating over string, nothing but n iterations. Here also n iterations. And this will be iterated for t times. So the time complexity is t into n. Moving to the third problem. The problem name is shall we play a game. So Alice and Bob play a game over n rounds starting with an initial score of 0. Alice take the first turn. In the ith round, ranging from 1 to n, the current player must either add or subtract 2 power I minus 1 from the current score. So the current score will be 0 here initially. So in each turn, either they can add or subtract 2 power I minus 1 to the current score. So in this process, x be the maximum score reached at any point and y be the minimum score reached at any point. So Ali's goal is to minimize the final difference x and y, while Bob aims to maximize it. Assuming both players play optimally, determine the final value of x minus y after all n rounds. Since this value can be very large, output it modulo with a given number. So in the input format, you will be having t test cases. In each test case, you will be given the round number, and you have to print the difference between x and y, where 𝗟𝗏𝗃𝗃𝗃 always try to minimize the difference between x and y, and Bob always tries to maximize the difference between x and y. Let's take an example and understand. Assume that these are the scores with a given range, and there are some n rounds. So the first round will be played by 𝗟𝗏𝗃𝗃, second round is played by Bob, 𝗟𝗏𝗃𝗃, and so on. Let's take the current score initially is 0, and minimum and the maximum value nothing but x and y. Okay, let's take in terms of x and y. So x is nothing but, let's take minimum and maximum for more clarity. Okay, so both are current score, minimum and maximum are pointing to 0. In the first term, 𝗟𝗏𝗃 can either add or subtract how much value? 2 power 1 minus 1, nothing but 1. 2 power 0 is 1. So from here, 𝗟𝗏𝗃 either he can add or subtract. Here I am taking adding plus 1. So maximum will be increased to 1, and now current score is 1. Next, 𝗟𝗏𝗃 round. 𝗟𝗏𝗃 can either add or subtract 2 power 2 minus 1, nothing but 2 power 1, which is 2. So from the current score, 𝗟𝗏𝗃 can add plus 2 or subtract 2. So if we add plus 2, it will go up to 3. If we subtract 2, it will go up to 1. So which one 𝗟𝗏𝗃 will choose here? He'll always try to maximize the difference between maximum element and the minimum element. So from this point, he will add plus 2. So current score will be increased to 3. So current score will be 3, and maximum value is also 3. So in the 𝗟𝗏𝗃 case, what is the difference between maximum element and the minimum element? Nothing but x minus y. It is 1. So here x minus y value is 3 minus 0, which is 3. From the current score, next it is 𝗟𝗏𝗃's turn. 2 power 3 minus 1, 2 power 2, which is 4. So from the current score, 𝗟𝗏𝗃 can either add or subtract 4. Will he add or subtract? If he add, the differences keep on increasing. So he will subtract 4. So it will go to minus 1. So current score will be at minus 1, and minimum value is at minus 1. So what's the difference now? X minus y difference is 4. 3 minus of minus 1, you'll get 4. Next, it's 𝗟𝗏𝗃's turn. So 1, 2, 4. Next, how much value he need to add or subtract by Bob? It's 8. So from the current score, this is a current score, which is minus 1. Will Bob add or subtract? As both are playing optimally, he'll always try to maximize the difference. So definitely will add. So when he subtract, it will go to minus 9. Bob will subtract 8. So current score will be minus 9. Minimum value will be minus 9. What's the difference here? X minus y, nothing but maximum element minus minimum element. The difference is 12 here. 3 minus of minus 9, which is 12. The current score is at minus 9. It is 𝗟𝗏𝗃's turn. So how much he can add or subtract? 16. Now, will he add or subtract? Obviously, he will add plus 16. So it will go to, if we add plus 16 to minus 9, you'll get 7. So the current score will be at 7 and maximum value is at 7. What's the difference between x minus y? The difference is 16. It's Bob turn again now. From the current score, if Bob subtract 32, so after 16, 32, if Bob subtract 32, then the difference will be reduced. So to achieve maximum difference, Bob add 32 here. So when you add 32 to 7, you'll get 39. So somewhere here 39. So what's the difference here? Current score will be 39 and the maximum value is also 39. So how to get the difference? Maximum element minus minimum element. So here, if you observe here, let's take all the alleged terms. Let's take alleged terms. So what are the alleged terms? Where n equals to 1, n equals to 1, 3, 5 are the alleged terms. If you observe the values here, when n equals to 1, what's the difference here? What's the difference? It is 1. When n equals to 3, what's the difference? It is 4. When n equals to 5, what's the difference? It is 16. So what you have observed here? What you have observed here? When Alex got the turn, he'll always try to not to add this value to the difference. That means this value will ignore all these values. Okay, I will tell you with one equation. So do you know that 2 power 0 plus 2 power 1 plus 2 power 2 and so on 2 power n minus 1 will be less than 2 power n? If you add, even though if you add all these values, sum of all these values will be less than 2 power n. So when Alex got this done, he'll try to ignore all these values, and in the difference only the current 2 power n value will be included. Only the current 2 power n value will be included. So if n equals to 1, then it is 2 power 1 minus 1. When n equals to 3, 2 power 3 minus 1. When n equals to 5, 2 power 5 minus 1. Nothing but, if it is Alice round, then answer will be 2 power n minus 1. X minus y difference is equals to 2 power n minus 1. Got it? So we know how to find the difference if it's Alice term. So now we need to find the value for Bob's term. So how can you get the value for Bob's term? Very simple. Let's take a equal 4. Let's take 4. So before 4 it is 3. Before 4 it is 3. It is nothing but Alice term. In the Alice term, what's the value here? It is nothing but 2 power 3 minus 1, which is nothing but 4. So when Bob got the chance to add or subtract 8, so what he will do? He will try to add this plus 8 to this 4. He will try to add plus 8 to this 4 so that the difference will be increased. He'll always try to maximize the difference. So instead of moving this towards right, he will move on the left side so that the value will be increased. So can I say that the value for the difference at Bob's turn will be the value of previous Alice turn value and the current Bob's value. That will be the answer. Simple here again. If you take Bob's turn here at 6, whatever the value you got here, 16, you'll try to add plus 32. So 16 plus 32, so that will be the maximum difference he can accept. So in the Bob's turn, how to get the value? In the Bob's turn, the n values will be 2, 4, 6, 8 and so on. So what's the difference? How to find the difference? The current value, how much the Bob is trying to add, plus the value of 𝗟𝗏𝗃𝗃's previous term. Nothing but x minus y, this difference is 2 power n minus 1, plus how to get this 𝗟𝗏𝗃's value, 2 power n minus 2. So this is how you can get the Bob's value. Nothing but the difference. So here, as I mentioned, that this value may exceed integer range, so you have to apply modulus with given number, and here also you need to apply modulus. You need to apply modulus. So the whole thing is, how will you find this value? 2 power n minus 1, 2 power n minus 1, 2 power n minus 2. Let's code it. So you'll be having t test cases. Okay, let's code this in Java for better understanding of applying modulus. Okay, so we have to first read the input. So I will create a scanner object. So to read an integer, _next_end. So done reading the number of test cases. After reading the number of test cases, you need to iterate a loop for t times. In each test case, you will be having only one integer, and n is nothing but nth round. So you have to print the difference at nth round. So _next end after reading n value. So how will you check whether it is 𝗟𝗏𝗃's round or whether it is Bob's round? Simple. If n mod 2 is equals to 1, then it is 𝗟𝗏𝗃's round. This is 𝗟𝗏𝗃's round. So what value you need to find out? You need to find out 2 power n minus 1. So if it is Bob's round, you need to find it is Bob's round. You need to find 2 power n minus 1 plus 2 power n minus 2. So to find out this 2 power n minus 2, what I'll do is, I'll write one function. Let's declare a static function. Let's take it as power. If you give n value, it will return 2 power n value. Let us take answer equals to 1. I will iterate a for loop I equals to 1, I less than or equals to n, I plus plus. So I will iterate for n times and I will return 2 power n value. So how can I return it? Answer equals to answer into 2. Finally, I can return answer. So this is how you can find the value. So to find out 2 power, I will call the power function with n minus 1. It will return the 2 power n minus value and I will print it. So in the Bob's case, first you need to find out n minus 1, n minus 2, and you need to, so first I'll find 2 power n minus 1 plus power of n minus 2. So after getting this, we are missing one thing here. So we know that this answer is not fit in the integer range. So in the question they have mentioned that you need to apply modulus. So you have to apply modulus here. So I will declare it as static variable. Now, so we need to apply modulus here. So when you are finding 2 power n, each time when you are subtracting with 2, it will exceed integer range. So what you have to do? You have to apply modulus, and when you are adding 2 power n minus 1 plus 2 power n minus 2, there are chances that it may exceed integer range. So again you need to apply modulus. Okay, let's run and check it. Okay, in the line number 12, okay, it is capital N. Okay, we got 1, 3 and 8. Let's see the sample output. It should be 1, 3 and 7, 6, 8. Yeah, that's correct. Let's submit it. That's it. It got submitted. So the time complexity is the time complexity is t into n. So the n here is to find out 2 power n value. So we are iterating for n times for each test case. Coming to the fourth problem, array operations. You are given an array of a of n positive integers, a1, a2 up to an, where n is odd, nothing but total number of elements are odd. You will perform the following operation repeatedly until one element remains. Choose any 3 consecutive elements in the array, say ai plus 1 and ai plus 2 for some valid index I. Remove these 3 elements and replace them in the same position with a single integer equals to maximum of ai plus 1, ai plus 1 comma, ai plus 2 plus 1. So your task is to determine the maximum possible value of the final remaining element if you perform the operations in an optimal order. So in the input format, you will be given 3 test cases. In each test case, you will be having 2 lines of input, the size of the array and array elements, all the positive integers. In the output format, you have to output a single line containing the maximum possible value of the final remaining element. So let's understand this with a sample input. If you're having only one element, so the maximum value will be 6 here. No need to perform any operations because already it is 1. So in the second test case, you'll be having 3 values, 2, 2 and 2. So you can choose any 3 consecutive elements. So I'll choose the 3 consecutive elements. I can add plus 1 to the first element and plus 1 to the last element. So what's the maximum among this? 3, 2, 3. What's the maximum? It is 3. So the output is 3 here. So for the third test case, you'll be having 1, 2, 1. So if you choose these 3 elements, you can add plus 1 to the first element, it will become 2. And plus 1 to the last element, it will become 2. So maximum among these 3 elements is 2. So the output is 2 here. Let's take one more example. Let's say you're having 3, 4, 1, 2, 3. In the question, as I already mentioned, that the total number of elements is odd. So it contains odd number of elements. So for this example, how many operations I can perform? Nothing but one operation is nothing but you can choose any 3 consecutive elements. You can choose any 3 consecutive elements and you have to add plus 1 to the first element and the last element, and you have to replace it with the maximum element. So how many operations you can do? So irrespective of the elements, I can choose these three elements. This is one operation, and whatever the element I got here, X element, again I can perform this with the including next two elements. So how many operations I can perform here? I can perform two operations, right? Now, so you can perform two operations here. So from among all of these elements, which value you will consider so that to get the maximum output, to get the maximum single value. Let's see, if you take 1 here, if you take 1, so if you want to increment 1 in each operation, you want to increment 1. So I will include these three elements. So I can add +1 to this value. I can add +1 to this value. So what will be the maximum value here? It will be 3. So among this, what's the maximum value? You can add +1 to this. You can add +1 to this. So it will become 4. So instead of this, so if you are trying to make this one maximum value, you are getting 4. But if you try to maximize 4, what value you will get? So I'll always try to keep this 4 either first or last in the 3 consecutive elements. So I'll try to take these 3 consecutive elements. So it will become +1 and +1 here. So what's the maximum among these 3 elements? It will be 5. Now you're having 3, 5 and 1. You can add +1 to 3. You can add +1 to 1. So what's the maximum element here? Maximum element will be 5. So you're getting 5 here. So can I get the total number of operations I can perform is 2. Can I somehow make +1 in each operation to this 4? Nothing but, can I get 6? Nothing but maximum value is 4. Can I get, in each operation I want to increment +1 to this 4, so that I want to get 6. Is it possible? Is it possible? It is not possible. So in this case, I'll tell you why it is not possible. So if we want to make it possible, in each time when you are performing the operation, this 4 should be either present at the first or last in the 3 consecutive elements, right? So initially I can take the first element in the 3 consecutive elements, so that +1 will be incremented, and I got 5 here. But in this case, this 5 is in the middle. I cannot add +1 here, right? I cannot add +1. So when it is possible? When it is possible? Simple. Let's take 2 here and 4 here. Now tell me, is it possible to get the maximum value of 6? Let's see. So if it is 4 here, I'll take this value, these 3 values. So I can add +1 here, +1 here. So what's the maximum value I can get? 5 here. So here, now 5 is at the first element in these 3 consecutive elements, right? So I can add +1 here. So +1 to this one. So I'll get 6, right? So did you guys understand when we are getting the maximum value? Nothing but total number of operation plus the maximum element in the array. Let's take one more example. Let's take 3, 4, 1, 2, 4, 3 and 2. In this example, so we understood that we can achieve the maximum value when you try to increment the value of the maximum element in the array. So what's the maximum element in the array? It is, we are having 2 maximum elements, right? Let's go one by one. So if you consider this value, what I'm trying to do is, I'm trying to maximize the value of this 4 in each operation until I get 1 element. Okay. So in the first operation, I will always try to keep this 4 either on the first element in the 3 consecutive elements or last element in the 3 consecutive elements. So before performing operations, can you tell me how many operations I can perform? First operation, I can consider these 3 elements, it will become 1 element. In second operation, I can consider 3 elements, it will become 1 element. And I can consider these 3 elements, so nothing but 3 operations I can perform. Totally, for making all these elements to a single element, it can be done in 3 operations. So in these 3 operations, in each operation I am trying to maximize this value. So to maximize this 4 value, which values I need to pick? I need to pick 4, 1 and 2. So that this 4 will be at the initial. So I can add +1 here and I can add +1 here. So what's the maximum among these 3 elements? It is 5. Next, I'll consider 5, 4 and 3. So 5 is still on the first element in the 3 consecutive elements. So I can add +1. I can add +1 to this. So what's the maximum value I can get? 6. So after here, now I need to take 3, 6 and 2. So here, can I able to put this 6 in the front or last in the 3 consecutive elements? I'm unable to put it. So I can increment +1 to this 3 and +1 to this 1, and I'm getting maximum element is 6 here. I'm getting 6. But what I'm trying to do to this maximum element, in each operation I want to add +1 so that it will get 7. But can I able to make it? Can I able to make it? I'm unable to make it with this 4. But is it possible with this 4? Is it possible this with 4? Let's see. So if you take this 4, 4 shall take these 3 elements. So I can add +1, +1. So it will become 5. Next, I'll take these 3 elements, 1, 2 and 5. +1 and +1. It will become 6. Now I'll take 3, 4 and 6. So 6 is at the last. So I can add +1, +1. So among these 3 elements, the maximum is 7. So I can get the maximum value of 7 here. So can you guys observe why I'm unable to make this 4 to 7 and when it is possible to make this 4 to 7? Why it is 7? Because to the maximum element, I'm adding the total number of operations. Total number of operations, nothing but in each operation, I want to increment my value by +1. So observe and figure out why it is possible for this 4 and why it is not possible for this 4. Simple. So for element which you are choosing, the maximum element which you are choosing, if that element is present, if that element have the number of elements on the right side is even and the total number of elements on the left side is even, then it is possible to make the maximum element plus total number of operations. That will be the maximum value. When you can able to, when you're having even number of elements on the right side, even number of elements on the left side. In the question, they already mentioned that the total number of elements will be odd. So when you choose this element, here it will be even, here it will be even. But in the first case, when you're choosing this 4, the total number of elements on the left side is 1, nothing but odd. The total number of elements on the right side is 5, which is odd. So in this case, when you're having odd number of elements on the left side, odd number of elements on the right side, you unable to make this 4 into the first or last in the 3 consecutive elements at one point. Simple. So when you're trying to make this element first or last in each operation, you can, here it will be first, you'll get 5. Again, here it is also first, you'll get 6. But when you taking 3, 6 and 2, you unable to make this 6 in the front or the last in the 3 consecutive elements. So that is where it is going when it is having odd number of elements on the left side and odd number of elements on the right side. So if you choose any maximum element, so obviously we can get the maximum element by picking the maximum element in the array. So we are having the maximum element here, and we are having maximum element here. So using this element, so how much value you can get, and using this maximum element, how much value you can get. So how can you get that value? Simple. So you can form value with this one. You can again form two operations. So total number of elements is 5. 5 by 2, nothing but integer division, you'll get 2. So you're having only one element, 1 by 2, you'll get 0. So 0 plus 2, this much value you can increment to this maximum value in the array, nothing but you'll get 6. So if you include this 4, you'll get 6. So if you take this 4, so even and even, so if you include these three elements, you can able to increment it by 1, and when you include these three elements, you can increment it by 1. When you take these three elements, you can increment it by 1. So how can you know this? Here you are having 2 elements, here you are having 4 elements. So 2 by 2, so 1 will be incremented when you do the operation with the right side elements, and 2 will be incremented 4 by 2. In each time you will include 2 elements. So 2 will be incremented when you perform the operation with the left side elements. So how can you write the code for this? So you can find the maximum element in the array. To that maximum element, what you have to do, you need to find out the total number of elements on the right side, total number of elements on the left side, and you need to find out how much value you can increment, and among all the maximum elements, you need to pick the maximum. Let's code it. So you'll be having t test cases. In each test case, you'll be having n length of array, and you'll be given array of elements. So this is how you will read an array in Python. First, you will read enter input as string and split it, convert to integer and convert to list. List is nothing but an array. So here what you need to do, I'll try to find out the maximum element max of array. So after finding the maximum, I'll declare answer, initially it is 0, and I'll iterate over the array, and I'll check if array of I is equals to maximum element. If array of I is equals to maximum element, you need to figure out the total number of elements on the left side, total number of elements on the right side. So how can you find it? 0, 1, 2, 3, 4, 5, and 6. So if it is the ith index, how will you find out total number of elements on the left side, total number of elements on the right side? Simple. So the index I denotes the total number of elements on the left side, and to get the total number of elements on the right side, so as we know that n minus I, n is nothing but total number of elements, I is nothing but total number of elements on the left side. So this will be subtracted, and you also need to subtract the current element, minus 1. This will give you the total number of elements on right. So I will give you the total number of elements on the left. So after getting that, you need to divide it by 2. So total number of elements on left is equals to I, and total number of elements on the right is equals to n minus I minus 1. So after getting this, how to get the how much value you can increment? Answer equals to maximum of answer comma. So you can add array of I plus or max plus left by 2 plus right by 2. Either you can replace this array of I with max also. So finally I'll print answer. Let's run it and test it. We are getting 6, 3 and 2. Yeah, it's correct. Let's submit and check it. That's it. It got submitted. And one more thing, instead of finding the maximum element also, here we are doing this operation only for the maximum element. So instead of finding the maximum element, you can do this operation for each and every element without checking this condition, and no need to find this maximum value. That will also work. So the time complexity here is t into n. So, and also they mentioned that t into n will not exceed 10 to the power of 5. That's it guys. If you found this video helpful, please consider liking it and share it with your fellow coders. For more such content, do subscribe to our 𝗏𝗏𝗃𝗏𝗃 YouTube channel. If you have any queries, drop them in the comment section.